Phosphorus can form 10 different types of oxyacids which are categorized into 3 different series, that is Us series, Ic series and Peroxy series, because the name of the compounds ends with the Us, Ic and Peroxy compounds. So let us learn the oxyacids of phosphorus and try to remember in an order. So the first one is metaphosphorus acid. Metaphosphorus acid. The formula of this compound is HPO2. This is the very first compound of oxyacid of phosphorus. Metaphosphorus acid is HPO2, which is a very weak acid, and its structure is P bonded to oxygen on either side with a double bond and on one side with hydrogen. This is the compound structure of metaphosphorus acid. And the second compound is metaphosphoric acid. The difference between the Us acid and the Ic acid is, compared to Us acids, Ic acid will have one oxygen greater. So HPO2, for this if we add one more oxygen, it becomes HPO3, that is our metaphosphoric acid. So the only difference is oxygen in this case. This is a monobasic acid. It's a monobasic acid. Let us look at the structure. Phosphorus at the center, connected to two oxygens on either side, and again connected to OH. Since hydrogen is directly connected to oxygen, this hydrogen can be replaced with other element, and hence it is a monobasic acid. This is the structure of metaphosphoric acid. Next one in the order is orthophosphorus acid. Orthophosphorus acid. The formula of this compound is H3PO3. Write P at the center, connected to oxygen on one side, and since there are 3 hydrogens and 2 oxygens left, 2 will be OH-OH groups and 1 will be H group. So here 2 hydrogens are connected to oxygens directly, so hence this is a dibasic acid. This is the orthophosphorus acid formula and the structure. But the next compound is orthophosphoric acid. Orthophosphoric acid. Just like we did for the previous set of examples, we need to do for this also. So compared to orthophosphorus acid, Ic acid will have one oxygen extra. So the compound name is, yes, H3PO4. So look at the structure above. One was connected to, P was connected to one oxygen with a double bond. Next we connect it with OH, OH and again with OH. So since there are 3 oxygens connected with 3 hydrogens, this is a tribasic acid. That means you can replace these 3 hydrogens with any other element. So orthophosphorus acid is dibasic, but orthophosphoric is tribasic acid. Next compound in the sequence is hypophosphorus acid. The name of the compound is hypophosphorus acid, where the formula of this compound would be H3PO2. It is H3PO2 where one oxygen is less than that of the orthophosphorus acid. So here the structure will be phosphorus at the center, connected to one double bond oxygen. The other will be OH. By this, 2 oxygens are covered up, but still we are left with 2 more hydrogens. So 2 hydrogens are bonded on either side. Since there is only one hydrogen connected to oxygen directly, this is said to be a monobasic acid. Next compound to learn in an order will be pyrophosphorus acid. This is hypo, and the next will be pyrophosphorus acid. Pyrophosphorus acid is H4P2O5. The formula is slightly different compared to the order H4P2O5, where we have PP connected to oxygen at the center, and both the phosphorus are connected to double bond O on either side, and both are connected to OH, and both are connected to H and H also. This is the pyrophosphorus acid, and it is a dibasic acid. It's a dibasic acid. And for this compound, if we add one more oxygen, we get hypophosphoric acid, which is hypophosphoric acid. The formula would be H4P2O6, one hydrogen greater than the pyrophosphorus acid. So write the structure as it is, but except for the POP linkage. So write the PP bond at the center connected to double bond O, double bond on either side. Then we get OH, 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 OH on all four sides. This is the structure of hypophosphoric acid, and this is a tetrabasic acid where there are four replaceable hydrogens. This compound is a tetrabasic acid. The next in the order will be pyrophosphoric acid. Pyrophosphoric acid, which is H4P2O7. We can remember these in an order. This is H4P2O5, H4P2O6, and H4P2O7. The structure of the compound will be POP linkage. Wherever there are odd number of oxygens, there we can find the POP linkage. Double bond O on either side, then OH, 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 OH. So this is also a tetrabasic acid where there are four hydrogens that are replaceable. So this is a tetrabasic acid. Next one in the order is peroxymonosulfuric acid. Peroxymonophosphoric acid. The formula of this compound will be H3PO5. H3PO5, where the central atom is anyways phosphorus, P connected to double bond O, connected to OH, OH. Since there are odd number of oxygens here and only one phosphorus, we can expect a peroxy linkage where the oxygen and oxygen are bonded. Due to this peroxy linkage, this compound is called peroxymonophosphoric acid, and there are three hydrogens connected to oxygen directly, and hence this compound is a tribasic acid. The last one of oxy acids is peroxy diphosphoric acid. Peroxy diphosphoric acid. Here the formula of the compound is H4P2O8, where one oxygen is greater than that of pyrophosphoric acid. So the structure is POO, P, double bond O, double bond O, OH, 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 OH. This is the structure of peroxy diphosphoric acid, and the basicity is again 4. So it's tetrabasic, similar to that of pyrophosphoric acid. And here also you can see a peroxy linkage. That is the reason the name of the compound is peroxy because two phosphorus are there. Diphosphoric acid because it contains the highest number of oxygens. So this is about the various oxyacids of phosphorus which can be studied under the name Assaseries ic series and peroxy series. There are 10 oxy acids of phosphorus.